We'll go ahead and get started. So my name is Kyle Johnson, and we're going to start talking about SkySplat. It's a Blender add-on that I created, and I have a colleague and friend, Garrett, with me in the audience that helped with a lot of the testing. So we'll be available all of BlenderCon for questions. But what is SkySplat? I want to show you a full walkthrough of how to do drone video all the way to photorealistic 3D models using 3D Gaussian splats, and doing it all from the Blender UI. There will be some software packages that we have to install. For people just coming in, that URL will have all the resources for this kind of walkthrough. All right, so a little bit of background about me. I'm a research engineer by training, 20 years in that field. And then within the last 5 to 7 years, really got interested in tinkering, kind of amateur 3D design, a lot of 3D printing. I talked last year about a 3D printed real topography moon, if some of you were here for that talk, and then how do you take complex mathematical shapes, render them in Blender with geometry nodes, and then make those more tangible. I also have a keen interest in physics simulation and all different aspects of making like the kind of mysterious physical sciences available and accessible to a lot more people. I'm also super passionate about education and science literacy. My wife and I are raising 2 young, voraciously curious kids, and I try to do everything I can to keep ahead of their curiosity and ahead of their questions. So doing things in Blender, 3D printing different objects and different designs is a good way to do that. Like I said, I also really enjoy spending time with my family. We like walks outside, and we live in a fantastic little North Yorkshire town. I do a lot of reading, particularly sci-fi. I run a science fiction book club in our town as well. And I try to get on the water as much as possible, but it's not as much as I would like, because I like to do sailing. And then more recently, lots and lots of AI tinkering. I know that's a 4-letter word in some circles, but I think it's really useful for some things while it's still maintaining the kind of the human ingenuity and the human creativity aspect of it. There's a couple of URLs there. The one that had the BCom 25 extension, so kyjohnso.com, that's got a lot of my kind of pet projects and different tinkering with 3JS and different renderings, and it's got a little bit about Gaussian splatting. And then ylabs.com, I think there's only a handful of things on there, but again, just kind of tinkering along this, figuring out how the world works, how to simulate it in 3D, and then how to make it accessible and explainable to people. So what is the vision? What are we doing here? What is SkySplat? So 3D Gaussian splatting, I'll talk more about what that is and how that's different from normal meshes. But it's really going mainstream, and not like pop culture mainstream. It's more like nerdy, computer graphics mainstream. But it's a new way of rendering photorealistic types of scenes. The original paper was published in 2023, and since then there's been kind of an explosion of open source, different academic implementations of it, and then recently this year we've seen a whole bunch of commercial applications and commercial pieces of software available for it. The problem is, because it's so popular and so powerful, the majority of the accessible applications that are kind of easy to use and have an easy workflow, they're moving to subscription models, and that's really locking out a lot of the tinkerers or the independent artists or the students that maybe just want to do this splat once. Maybe you want to go fly a drone in a park and just do this like one scene, and you don't want to get snared in a big subscription model tail just to do that one scene. There's a ton of open source solutions. The original implementation of the code was in open source. However, some of them have pretty restrictive commercial license, so you can do anything you want with it, amateur or kind of research, but as soon as you want to use it in some sort of revenue generating system, they restrict you from doing that. Or, and I'll talk more about this, they can be kind of hard to use in terms of the different tool chains, the different pieces of code that you stitch together to do that. So a little bit about Gaussian splatting fundamentals. What is it? So instead of your scene being made up of vertices, edges, triangles, and meshes, we're making them up of thousands, tens of thousands, hundreds of thousands, some cases millions of 3D Gaussians. it takes the term Gaussian from the statistical distribution. It really means it's kind of like the bell curve, if you remember from grade school, or if there's engineers or scientists, or I mean, this even crosses over into computer graphics. It's like kind of like a sphere that's been squished and rotated and colored in different ways. So we make up the scene of all of these Gaussians, and we start with a big kind of not random but not perfect distribution of these millions of these things. And then what we can do is we can change the position, the scale, the rotation, the color, the opacity in order to match these training images that we have. You'll see that happen in real time when we run the brush app, but you can kind of think of it as if Suzanne down there in the right-hand corner was, instead of made up of meshes, was made up of a bunch of these Gaussians and a bunch of these kind of squished and rotated and opaque spheres. So what was the problem? What am I trying to solve here? So started tinkering about 18 months ago with 3D Gaussian splatting, and most of, if you're familiar with photogrammetry, most of the advice for photogrammetry imagery and taking pictures is do it from a bunch of different angles, do it kind of in a bunch of different circles around your object or your subject, and that makes for good angular kind of separation in order to do that. We also got into flying drones, and like the drone, the ability to stay at a level angle, the ability to kind of keep a subject in focus and in the center of the frame, that's kind of what those things are made to do. So it's a really, really good workflow from drone footage to 3D Gaussian splats. But like I said, the workflow is either complicated or proprietary or kind of expensive. I'll mention this reshot.ai 3D Gaussian splatting tutorial. I dove through that multiple times in a row. It's a really, really good tutorial on what is Gaussian splatting, what are some of the tips and tricks to get that to work. So what's the problem? When I dove into that tutorial, it was like a sea of trying to navigate through the command line. And I was doing it on Linux. It's the same thing on kind of Windows or on Mac. But there's all these different Python packages you have to install, and you have to make sure you have the right CUDA license, and or the CUDA driver versions. So it was like, I'm gonna definitely date myself here, but it was like the old command line games. If you guys remember, like Zork and then Zork 2, and when we finally got to return to Zork, then we could finally get some graphics. But it felt very much like that. Like you go into the house and you look on the living room table, and there's this DJI underscore date stamp Windsor Silo New small .mp4. So what do you do with that thing? How do you turn that thing into a 3D scene? There's also this, I call it the coordinate system crisis. So most of my computer graphics is native to Blender and not necessarily other kind of mainstream computer graphics. So for the rest of the world, the y-axis is the vertical axis. For Blender, z-axis is the vertical axis. So for the Gaussian splatting world, it's the y-axis. When you try to import it into Blender, you get what you see there, and you'll see this again live, but it's all tilted and it's angled, and COLMAP, the structure-from-motion, treats the image frame different than it treats the actual point cloud frame. So how do you handle that? How do you adjust for that? And then, yeah, like I said, to transform or not to transform, that's the real question when you're importing PLYs into Blender. And I won't go through this in too much detail, but there's this subscription trap. Late 2023, the original paper dropped on archive to do like a new way of, because it was a neural rendering technique for radiance fields, much faster using this Gaussian technique. The paper was open source and the code was open source, and they have example data, but it was a non-commercial use license. Postshot came out and offered a 3D Gaussian Splat beta version in 2023, kind of right on the heels of that. The initial commit to the Brush app, which is a Rust-based open source and then pretty liberal license application for 3D Gaussian splatting. That was the initial commit, was kind of right after this initial publication. And then the Kiri Blender add-on for the Kiri engine, that was the initial commit, was kind of late last year, or about a year ago. And then I really started like taking a look at this in kind of mid-May. What you see at the bottom there is that we had some open source, we had some liberal license, we had some good free ways of playing around with these things, but slowly those things are getting kind of clawed back into the either you pay or you don't get the features type of structure. So I was faced with this dilemma. Do I learn the command line tools, or does everybody else learn the command line tools, debug the Python environment? 5+ different applications is maybe a bit of an exaggeration, but not much. That's quite a bit of different things you have to learn in order to do this. And maybe you get a result in a week or weeks, or you pay and you have like this nice integrated kind of workflow. What we're trying to do with this, and with really heavily leveraging this Brush external app and SkySplat, is to do this, you have to open Blender, which everybody in this room knows how to do that. Maybe not, which is, if you're here, that's awesome. So we'll work on opening Blender. Import the drone video, and I'll talk through that. Step through all the same steps that you would on the command line, but you never have to leave the UI, never have to leave the 3D viewport. And then you edit your 3D Gaussian splat. You can edit it together with other meshes that you have, with other parts of your scene, with references that give you some sense of scale. And then you render it, and all these are familiar tools. And maybe it's a day, maybe a weekend to do this. And that includes, I'm confident in you guys, that includes going out and flying the drone for an hour or two as well. So a little bit about like the high-level design, and then we'll kind of dive into the installation and the walkthrough. I didn't do any like algorithmic heroics here. This is really stitching together some open source tools that are well established and have, sometimes small dev teams, but other times long dev teams and big dev teams. And they're all, doing really, really good work in the open source community. So COLMAP, I'll talk a little bit more about what that is. It's a structure-from-motion application, been around quite a while. I talked about Brush. I'll go into more detail on that. That's the actually doing the moving of the Gaussians around to match your images. And then, of course, Blender. And this workflow, creating these types of things, would not be possible without all three of those types of open source contributions. It was designed as a Blender add-on, so you never have to leave the viewport. And then it's really designed for, in a 3D sandbox, having one spot where you can edit the COLMAP model, where you can edit the splats, where you can have other 3D assets and 3D objects and 3D meshes in your scene, and you can do all of this in one spot. One of the big problems with the custom-made Gaussian splatting software is you can do some editing on the Gaussian splatting, but then it's really hard to bring in other assets. Blender's fantastic for that because it's got a lot of different ways to kind of include these things. I'll talk a little bit about other like non-vanilla Gaussian splatting, where you can like track motion, you can do underwater scenes. There's a whole explosion of different research on these things that eventually want to have like Blender as maybe a stop spot to call all these different pieces of software. All right, so let's try this. Let's try the install and try the walkthrough and see how we get on. I mentioned it a little bit before I started. If you have problems, don't fret. We will be here all week. We can, go up to the different rooms and chat and kind of figure it out. I would love multiple people to try this out, but it is going to take a little bit of time to kind of work through this, so I want to make sure we get all the way through that. So if you have questions or problems, just kind of hold that to the end or to the rest of the conference. So the first thing is SkySplat install. I heard that we needed to get it on the extensions platform. We'll figure out how to do that, hopefully by the end of the week. But for right now, the link was in the original kind of assets that I gave you guys before, but you can just go to this one as well, and it's going to be a GitHub page. So I manage all of this through GitHub. So you can come down to the releases, and then if you scroll down to the bottom, there's the SkySplat Blender, the current release. So you just download that. When you get to it, you can just mouse that over into your Blender UI, or go through the settings and do it that way. I'll take a quick pause. That whole add-on install process is awesome now. I know there's been a ton of work on that, a ton of work on bifurcating kind of the local add-ons and extensions. It's a pleasure to kind of do that and to just be able to code in that type of environment. All right, so that's the SkySplat piece of it. And then the next piece is this Curie engine. So this is what we actually use to load in the 3D Gaussian splatting and the rendering of it. So this is not my add-on. This is the Curie Innovation folks. Really, really good way of loading it in and doing the rendering. I didn't want to have to replicate that necessarily right off the bat, so we're going to use that one as well. Same exact GitHub. You go there, you go to the releases, and then you download their latest release, drag and drop into Blender, and we're off and running. COLMAP's a little bit different. So COLMAP, again, has been around a while, and when we're actually running it, I'll tell you guys kind of what it does, and I'll wave my hand some more, and we'll see if we can get to an understanding on how that works. I have, so on my README, on the SkySplat GitHub page, there is pretty well tested, but could still use some more testing, installs for COLMAP, for Brush, a couple of different ways for all three major platforms. So would love for you guys to kind of work through that at your leisure or right now and just maybe give me some feedback on how that works or if it doesn't work or why it didn't work for you guys. If you're on Mac OS and you use Homebrew, that's kind of the recommended way. Just do brew, install COLMAP, and you'll get what you need. That works with the Apple Silicon. If you're on Linux, the Ubuntu, Debian flavor, sudo app update, and then install COLMAP. And then Fedora, Red Hat, kind of similar for their DNF system. And then on Windows, so this one's a little bit different than the others, there's the COLMAP GitHub page. You can go down to their releases and install and just download the executable for that for COLMAP. Regardless of how you do the install on your system, just make note of where that install binary is. If you're on Linux or Mac, which COLMAP will kind of tell you where that is. When we get to actually running it from Blender, you'll need to know that. I think we did a pretty good job of trying out automatically a lot of the common places for the different platforms, the different systems. But if you do it in a different way, or if you install from source, you might need to just make note of that location. And then Brush. So Brush, again, managed through GitHub, relatively new, but they have some fantastic, they build their executables as well. I was chatting to somebody about Rust development, if there's another quick aside. Anybody that's interested in like the future of Rust in Blender and Rust development and how that interfaces with Python, super keen to talk about that this week. I'm really, really interested in that. Arthur Bushy, the guy who maintains this, does precompiled binaries on his github.com page. Also in SkySplat_Blender on mine, I do precompiled binaries as well. And you can also, of course, if you want to kind of bite off installing it from source and building it from source, you can do that as well. The Rust build pipeline's actually rather good. On Mac OS and I think on Windows as well, if you download an application from the internet, it's going to try to protect you. That's a good thing. But you might have to do some heroics to get your computer to let you run these external binaries. I'm really interested in what Hans is doing with the binaries built into Python that are built into the add-ons that will directly run. But Blender, understandably so, if you just have a binary in the zip file, it will not, and you install that, it will not allow you to make that executable. So again, just some kind of a little bit of heroics, but hopefully over the next couple of releases we can smooth that out a bit. All right, so that's the install process. Let's actually get to walking through what this actually looks like. I already have Blender up. I'm not going to delete the default cube because I'm going to use the default cube. So we don't have to do that joke again. I run it from the command line. You get a little bit more logging detail, a little bit more what's going on under the hood, especially with these external applications. You don't have to. You can it'll still work, no problem, in the UI. But if you want to get a little bit more detail, you can do that. So it's going to install just like a normal. Everybody see that? Maybe a little bit bigger. So it's just going to install and have that pane for you available on the side of the UI. And it's going to be organized into three kind of sections. We're going to have the video loader, we're going to have the structure from motion, we're going to have the Gaussian splatting. So let's start with this. We're going to open up, just using the normal Blender menus, the video that you guys downloaded. And what this is going to do is it's going to, when I hit the load video and SRT button, it's going to read that in. It's going to update how many frames that is. It actually loads it into the video sequencer as well. And then what it's going to do is it's going to default this frame step value. And this is like, we don't want to take every single frame. That's quite a bit of computation. So we're going to skip a certain number of frames, and then we're going to send that to the COLMAP process. So this is defaulted to give you about 175 frames for your video. If you have a really big video that's going over a whole city block or a whole neighborhood or a whole park, you might want to adjust that a little bit to get enough angular resolution on your video frames. But for this video, for everything that I've done so far, this is a good number that it'll default to. And then we're just going to hit extract frames. A little bit of a kind of inside baseball design detail here. The extracting frames and running COLMAP it blocks the Blender UI. The extracting frames doesn't necessarily have to block the Blender UI, but the COLMAP, it's a couple of different command line arguments that are kind of obscured from you guys. So it turns out to be kind of difficult to run COLMAP without blocking the UI. So go over to your command line, go get a cup of tea, do kind of different things while that COLMAP piece is running. So this already finished. What this did is it extracted these frames every 22nd frame, and it extracted it into a file or into a folder that you can control this, but it'll take the name of your file, your name of your MP4 file, and it'll default the frame write location to be that same exact name, just without the extension. So you're going to have a couple of different folders that get created that have the same exact name as your movie file, your MP4. You can change all that in the UI. You don't have to use those suggested defaults, but it just makes it a little bit easier the first couple of times you're going through it. All right, so we've extracted our frames. Now we're going to open up the structure from motion. Again, worked somewhat hard to make sure these things default to logical locations, and then especially where it's reading in the files and reading in the different types of images. But you might need to monkey around a little bit with this in order to get it to work. This very top bit, this COLMAP executable location, that's where if it didn't pop up with some default there, you probably need to go figure out where COLMAP is installed. And you can just navigate there via the folder icon, but you probably need to go figure out where that's installed in order to get COLMAP to run. Just a quick, we're not going to stop, but just a quick show of hands, who sees that little COLMAP executable up in their corner that's following along? We have one. Okay. That's not a good start, but that's okay. That's okay. Like I said, we'll be here all week. So what we're going to do, we're going to run COLMAP, and then I'm going to just pop this up again. This is going to step through and show you the different things that it's doing. And I'm going to take this opportunity, this should take a couple of minutes, to really talk about what COLMAP is doing. So COLMAP, we just give it 175-ish images of a scene from different angles. And what it's doing is it's going in and finding pixel features in each of those images that it can identify as like a high contrast feature. And then it's going to, and that's what it just did. We get about 10,000, 11,000 features per image. And then what it's going to do is it's going to say sequentially, the sequential naming of the frames, I'm going to try to match up those features. So under an affine transform, which features in frame 1 match which features in frame 23, because we step by 22. Then once it has those matches, it's going to go through the mapper, which is it's doing now. And that is saying, okay, I have the XY position of a feature in a frame, and I have a different XY position of a feature in a different frame, and I know it's the same feature. I can do the matrix inversions and the coordinate transforms to say, where are my two frames? If I have a bunch of different features, where are my two frames in 3D space? Where are they located? What's the angle of the image, of the pictures, of the cameras? And then where in the 3D scene are the points? So it's trying to localize, so structure from motion, this 3D structure from like having motion in your scene or motion between your frames. So while that's running, it should take just a couple of minutes. We'll have a little timer to see how fast it's actually going, and you guys can check me on that. I'm going to come back up here, and I'm really curious, while that's still running, actually, yeah, let's get to the video capture kind of top tips. I already talked about this. If you keep the drone level, do a big circle around, or there's nothing special about this being drones. It was just a cool application. You can do your handheld camera, you can do a phone, you can do whatever you can capture video or images with. It's just drones give you this nice level. You keep one joystick in, one joystick out, and you kind of keep that subject in the center, and then you change your altitude and do it again. Change the range to your subject and then do it again. And you can kind of see, this is the output of COLMAP from the full video that I did, that you get these really, really nice level circles around your subject. So this is what I wanted you guys to think about. We won't go through all these quite yet, but as you guys see how to take this video or drone video through these different steps, and you can see kind of what we can do with it, I want you guys to think about what we can create together, what you guys can create. There's some obvious things like I just want to use the 3D Gaussian Splat as a direct asset in my film or in my game. I think a cool application is like a modeling guide. So you can currently have a really good way to import Blender reference images and then model it according to those reference images, kind of on the isometric view. What if you could do that in 3D? What if you could have like a 3D representation, but you still wanted to make the mesh, you still wanted to be artistic about it, you still wanted to have your own style on it, and you wanted it to be somewhat faster, different integration in a different type of rendering pipeline. You could use this just as a reference for your creation. Yeah?
I would like to measure something like based on the
yes.
feature I see.
Yes.
And that would be a nice implementation.
Yeah.
Like a feature extractor.
Okay.
And you point at some color or like a structure.
Yep.
And it detects from a little.
And you like measure the distance.
Along, yes.
Yeah.
And you have this triangulation.
Yeah. It's not scaled through COLMAP. I'll talk about why Blender is awesome at making it scaled, and that's one of the main features of this. So yeah, modeling guides, making measurements, measuring heights, measuring the area of something, and then applications for architecture. You can do this for a city block, and then virtually raise a building to the ground, and then build it back up with whatever you're building, your architectural dream. We'll get to the education and travel because, like I said, I'm particularly interested in that. But let's go back over and see how we did. COLMAP processing completed under 200 seconds. That's a little bit over 3 minutes. I'm running on pretty decent hardware, so your mileage might vary, but it runs around the same on like a decent workstation GPU as well. All right, so we're going to go back into Blender, and now we ran COLMAP. And then it's going to output a database of the camera models and output a database of where those points are, where the cameras are, and then you can just directly load the COLMAP model with this button right here. So there we see what I was talking about. We have this coordinate system kind of catastrophe here. It's not all lost because we can use Blender modifiers and use Blender translations to kind of get this right sized. I will say it imports this COLMAP collection and then the COLMAP root, and those are the default names. You can change those. Underneath this, there's a bunch of cameras. All of your cameras with their original frame number and name is there, and then we also have the point cloud. So that's important, and I'll tell you why after we do the Gaussian splatting. But if you're going to modify this and rotate it, just select the COLMAP root aspect of it, or the COLMAP root empty. So we're just going to rotate that one empty. It rotates all the cameras, all of the points, and it keeps everything. It's really important that COLMAP did all this work to figure out where the cameras are, where the point cloud is. We want to keep all that relative to each other, all that scaled. But we can rotate it. We can move it up in this axis. We can scale it up, and I can move it up here. So we're kind of I have guilty knowledge that this is the silo right here, these kind of rings, these high contrast rings it detected. And then I'm just going to kind of center that up in X and in Y. Maybe I need to grab it, move it a little over Looks like we maybe need to rotate this a little bit. And now we have a, pretty reasonable point cloud, pretty reasonable, all these different cameras, all these different things that we can reference on where that image was taken from. But we don't know how big this is, right? We want to measure. We lost all that information because we didn't give COLMAP any camera information. That is a feature that will come, is taking advantage of this SRT, when we go up here. This SRT file, that's all the where the drone was, what the camera parameters were, where was it pointed, all of that information that we could definitely take advantage of when doing COLMAP. But for right now, we're just kind of stuck with Blender, but Blender can still do quite a bit. So what we're going to do is on the resources page at the very bottom, there's an image from Google Maps. If we go and just grab that image, and I have it right here, drop it in as a reference, and I'm just gonna hide the COLMAP model for a second. So this is it's in Windsor, Colorado, kind of where my family lives. I just wanted to grab something that I could say, how big is this silo? How big is this area? So you can see that we have the scale of the image is here. Another awesome thing about Blender is I can just take and, go to the item, and it says 50 feet, but I'm in meters. Well, that's okay, because I can do 50 feet. And I can make that a 50-foot cube. And I can grab my empty, and I can scale that up, and then I can get this about right with where this cube is. And I'm going to kind of short circuit this a little bit, because I really want to get to the 3D Gaussian splatting bit. But what you can do is you can then take your COLMAP model and line it up, and we can rotate it so we can get like these streets aligned, grab it. It looks like we need to scale it a little bit more, because now we have a cube that's 50 foot on a side, a map that's 50 foot on a side on our key, and now we've scaled our COLMAP. So in the absence of using all that extra data, we still have recourse, because Blender is awesome, to bring in those extra reference images and assets. All right, so now we have a scaled, rotated COLMAP model. We're going to go back here to the SkySplat panel, and we're going to, we have to export that first. So we rotated it and scaled it. We need to export that model. And once that's exported, we do the prepare brush data set. I'll talk a little bit about why that is, what that's doing, but first I want to just kick this off and run brush. There's a lot of options in brush. A lot of things to tweak around. Where you're moving around millions of Gaussians, there's a lot of decisions you have to make. It defaults to a lot of the ones that work. And then this one, the with viewer, leave that one checked, because if everything works out and you have your brush executable path here, and then you run brush training, it'll pop up this image that is, it's calling out to this external Rust code, but we didn't, remember, we didn't leave the Blender UI, and it is taking the images that we had, the COLMAP model that we had, and then moving around these Gaussians in order to make those images match up to the Gaussians. And you can, the brush is one of the only applications I've seen that does this. You can watch it, update it live. A lot of the other ones, you just throw it to the GPU and let it churn, and you hope you get something back and you don't run out of memory. But this lets you like see it live and see what's happening. And then you can also step through all of your reference frames in order to see kind of, this, the bottom is the actual image, the top is the 3D Gaussian splat, splatted image and rendered for that particular camera location. So really, really powerful. We're going to let this run. It's at training step 830 or so. We're going to let this run over to 5,000 steps. And then we're going to, while that's doing that, and then we're going to import it, and we'll do one last cool thing. But while that is running, we're going to step back over here, and we're going to kind of come back to the what will we create bit. I mentioned, real estate is a really important field, and it's a really lucrative field. But so there's real estate standards being talked about for this 3D Gaussian format. I feel like there's a lot of other really cool applications that we're going to learn about and talk about at this conference. But then education and travel. So we cannot have every school child travel to every UNESCO World Heritage Site around the world. We can't have everybody travel to every different museum or cathedral. But having this, like I went out and created just a couple of drone flights, and then we have this photorealistic model that we can bring in to Blender and do all of the different rendering after that pipeline. So we can go to VR, we can go to just a film, we can go to a promotional video, we can go to like whet the appetite of a field trip to go to someplace. But the ability to like see it and rotate it around in 3D and like really fly through these environments, I think is like the most powerful way to have that connection with what these things look like and what they kind of feel like. And then travel, you can imagine like lots of different local tourism boards that can't afford, high-powered commercial photography. You could have, a hobbyist or some local citizen that really wants to help out their town, do a 3D Gaussian splat of the town, and then they could use that on the web. These things render amazingly fast in the web. So this is me kind of riffing on this idea. I know you guys have lots and lots of other really, really cool ideas. And that was the whole point of this talk is like, let's figure out some cool things that we can build together. I would love for you to use this pipeline. If not, that's fine. There's lots of other 3D Gaussian splat pipelines, but let's build some cool stuff together. All right, let's go back over to Brush and see where we're at. Okay, we have a couple more thousand to go. Let's see. Yeah, I'm just going to kind of let that run. We still have time. Is there anybody that I know you talked about features that you wanted to see? Any other ideas on that you think you might want to try using this for while this is still running? Mesh generation. I know that's a big application, right? Like you still want to mesh, and these are fundamentally different than meshes, but it's a really, really good reference. Another quick thing I'll mention. Oh yeah, go ahead in the back. Yep. If it runs out of GPU memory, the Brush app will likely crash. So the running out of memory, I was talking more about like the academic implementations of 3D Gaussian splats. I've never had Brush run out of memory, and I've done really, really big, many millions of Gaussian splat scenes. Yeah, question?
Can you relight this later? If you, for example, film this like more in a copy day, like photogrammetry?
Yep. Yeah, good question. The question was, can you relight it later? I mentioned other different applications of 3D Gaussian splatting and like underwater scenes and capturing motion for 4-dimensional Gaussian splatting. Relighting is another like kind of academic application where you have this directionality specific color. So it implements the color of each Gaussian as a spherical harmonic, so it can accurately represent reflections and glare. And then just diving in and changing those parameters, there's applications where you can recolor it. You can change the color. You can like remove the like bright lights that you have from the sun and then recolor it with your lights that you want in your scene. I can't do that here with the Brush app and with the Curie engine. There are some modifiers there, but that's something, there's like been an explosion of research articles on this and research papers. So those are the things, and that's why Blender is like a really good kind of consolidated place to kind of hold a lot of this stuff. Yeah?
Just for other representations, there's work going on at Alliance for OpenUSD.
Oh, right.
Schema
Okay.
for splats.
Okay,
So
fantastic.
then that just puts it in the whole USD ecosystem.
Yeah, fantastic. So the comment was there's work going on in the OpenUSD Alliance, Universal Scene Description Alliance for how to represent Gaussian splats, and that like opens it up to that whole, everybody that uses that standard, which is fantastic. It's like a really different way of representing 3D scenes and a way to do that, and it's complementary rather than conflicting with.
Supports it, so.
Yeah, yeah. So it doesn't support 3D Gaussian splats natively currently, I think, but it's more like when it implements OpenUSD. All right, let's go back to, okay, we're over 5,000. So you can let this chug along. The default was it's going to output every 5,000 steps. We're going to stop training. Another thing that's awesome about Brush, you can just pause the training and then restart it later if you want. But now we're going to hop over to the Curie engine. And that is, again, on the side with this 3D GS renderer. And what we're going to do is on the import, we're just going to hit the import PLY as splats. They used to have the option to adjust the axes. They don't anymore. They just said, don't apply the rotation. Just do that with Blender. So I think that's a good modification, a good update. So we're just going to hit OK. We're going to go to the desktop, BlenderCon, and you see that using the defaults, we output this small brush output, the 5,000 PLYs, and we're just going to import that as the PLY. It's going to take a little bit. I don't know how many actual PLYs or actual splats we had. We had like 1.08 million, I think, for that. So this imported it as, and I'll just go to wireframe real quick. So the way that the Curie engine implements this is the splatting bit is it needs to smash a 3D Gaussian to a 2D plane and then layer all those planes in order to render what that image, that pixel color is. I'll talk more about that maybe offline or maybe later, like why that is, why that's important, why it does that. That's where the name splatting comes from. But what it means is that currently, when OpenUSD implements Gaussian splatting and Blender inherits that, it's going to be fantastic. But currently, we have to make sure that we enable camera updates, and then this update to active view is going to change all of those rectangles, those splats, so they're facing our camera or our current view. So what we have now is this original COLMAP model with all the camera angles, with where everything is, and then we also have now this Gaussian splat that we imported. I'm not going to go through actually how to render that. The Curie folks have fantastic documentation and videos on that, but what I will talk about is why I wanted these frame numbers to line up. So if I go to, I'm going to turn this into show as a point cloud, and I'm just going to tick this up a little bit so you can see all the Gaussian splats as a point cloud. And now when I say I want to take my camera and I want to make it emulate the position and scale of frame 133, for instance, I can copy the location and copy the rotation of that. And now when I go to my camera view, let's get rid of we don't need the default cube anymore. When I go to my camera view, I have the same exact position as frame 133 of that video. And I can turn this to frame 133, and then that's going to have the same exact, in the video sequencer, position as that. So you guys are probably already thinking about why would that be useful. One more quick thing, and then I'll talk about why that is. COLMAP will also figure out your camera focal length. So we need to come in here, and you can see it's a little bit smaller. We'll go down here to the camera, and then we'll copy that focal length up to our camera. And then, oops. There we go. So now we have that full scene. And if I think I still have time, I'm going to change this to the video sequencer so you can see we're at frame 133. We'll just do this, change it to use time code, unselect that. So now we're on frame 133. And if we take a look at the actual preview, we have the same view here in our render as we do in our drone video. So you guys probably know where I'm going with that. And I'm going to, and again, to encourage you guys to think about what the art of the possible is to make with this. Put together, I'm not a filmmaker, so please don't judge too critically. It's a little bit rough around the edges, but hopefully you guys enjoy this view of what the art of the possible is. Thanks, everyone. So you might have seen that last sequence. My daughter really wanted to redo her room in the style of the Zelda Sky Islands, and I started to mock it up in Blender, and I'm not a very good Blender user. So I'm like, okay, this kind of looks good, and I'm like, wait a second, doing 3D Gaussian splats from drone footage. You're an excellent Link pilot. How about you pilot Link through the Sky Islands, and we'll get that video, and then we'll use SkySplat to make a 3D Gaussian splat of the Zelda Sky Islands. So that's what we did with that. Thank you, everyone. Thank you. Special thanks to the developers at Brush, especially Arthur Rashi, the COLMAP developers, Kiri Engine devs. Garrett did a ton of testing for me. Will be available to talk about kind of different things that we need for this. Yeah, my daughter Hannah and my son Lucas for excellent drone accomplices, sometimes pilots, and then I can't fly Link around that thing to save my life, so they did all of the video gaming for that. My loving wife Sarah for she doesn't tolerate, she really encourages these crazy hobbies of mine. And then of course to the developers, the entire community at Blender. Being able to create something that's in your head and like bring that into the world and share that with people, that's like fundamental to the human condition. And the folks at Blender and the team and then all of you guys and the entire community really make that happen and make it like a really, really unique tool where we can get filmmakers, video game makers, hardcore computer software developers all together for a couple of days to really talk about what cool things we can build. So thank you guys very much. I really appreciate it. I think we maybe have a couple of minutes for questions, but like I said, we'll be wandering around and having different conversations. So any other questions before we all part?
Yes, so what happens if you have some moving objects?
Yeah, so moving objects, there's like some of the scenes I have like cars driving through them and stuff. It really depends on how many different images you have of that object there. I didn't do any masking of Link in the video game capture, and that's a moving object, right? It's like in the 3D scene, he is moving around. And I took off a lot of like the UI aspect of it and the heads-up display, but it still has Link. So it depends on where the moving object is at the different frames. But you can do, with all of these applications, Brush and COLMAP, you can put in mask files where you mask out certain parts of the image. Awesome.